All right, and this is the lesson 2.1, conditional statement notes. So a couple different goals for us, different type of math lesson than you're probably used to. We're going to write some conditional statements in if-then form. We'll talk about converse, inverse, so a little bit more, a little bit more writing probably than you're used to. And then we'll add a property here at the end here, or a definition, and then see how we're going to use that in some of our explanations. So let's just jump in. Let's get it going. Try to make the video manageable time-wise. So here we go. What the heck is a conditional statement? So in our notes, here's what we added. We added, a conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. Don't get hung up right now. This is straight from the textbook. With P and Q, we're not going to use those letters. This down here, P, arrow Q, none of that. Okay, so it's really just a logical statement with two parts, a hypothesis and a conclusion. We are going to work almost exclusively with if-then form. So that's another vocab word that we talked about as far as under this blanket of conditional statements. So a conditional statement is very broad. It's just a statement that has to have two parts, a hypothesis and a conclusion, where a conditional statement is just a specific type of conditional statement. Or I'm sorry, an if-then form is a specific type where it's going to be written as, if, in whatever our hypothesis is, then some conclusion. All right, so yeah, for us, for this lesson, and for pretty much the unit, everything's going to be written as kind of an if-then statement. If this, then that. All right. So just a straight up example, we'll look at stuff that's math related and, or math content. And this is an example of one that's not, more of like a earth science one. If it is raining, then there are clouds in the sky. So we've got a hypothesis that it is raining and a conclusion that there are clouds in the sky. Notice we're not saying anything about true, false, anything like that. This is just a straight mechanical, where do these things go? If the hypothesis, then the conclusion. All right. We could see mathy ones, a little bit more. This is more of like an algebra, pre-algebra type of concept that if A is a positive number, then the absolute value of A equals A. So again, whether it's, more just relatable or something that's specific to math content, not the point of it here is just kind of understanding where the hypothesis and conclusion fall. All right. So one of the skills that we've got to be able to do is, example one here is turn the conditional statement into an if-then form of that statement. So this is an example. All vertebrates have a backbone. That's an example of a conditional statement. There's a hypothesis and a conclusion in there somewhere. It's kind of for us to decide, and it's really somewhat open-ended that we can, whatever we want to make to be the hypothesis and the conclusion, turn it into if-then form. So all we're doing on a problem like this, when we're rewriting something in if-then form, obviously I got to get those words involved. So if, and most of the time it involves injecting some sort of subject. If you or if it or if the thing or if the person is a vertebrate is an example of how we can do this. So if, let's say, the animal is a vertebrate, I'll space it out there a little bit, is a vertebrate, then it has a backbone. All right, just an example. Could we have worded that differently? Sure, we could have. Maybe you saw it as if the animal or if the thing, if the creature has a backbone, then the animal is a vertebrate. So we could have said it in, kind of a backwards way there, and that's totally fine. So there's some open-endedness as far as how you're going to approach an exercise like this. So don't make it harder than it is. Yeah, there it is. We'll do two other ones while we're here. We may as well just turn these conditional statements into if-then form. All right. Be careful here. I'll give maybe a good or an example of a bad if-then form, because sometimes people do this and I see it a lot. So sometimes people would say something like this. So here's an example of a not what to do. We'll kind of X it out. But if a triangle has 3 sides, then, well, then what? Like, I don't know. The problem is, and maybe you can see it, is I've stuck everything all into the if part. If a triangle has 3 sides, and hopefully that's not really an if, a triangle by definition has 3 sides, so there's not really an if part of that. But you can maybe see what I screwed up with here, that if a triangle has 3 sides, then what am I supposed to say next? That I basically got to create something out of thin air. Then it is a right triangle, which also would also not be true, or it would be kind of a bad statement. So don't make it harder than it is. This is one I would say something along the lines that would be better would be if the figure or if the polygon has 3 sides. So maybe we want to say it kind of the other way, has 3 sides, then it is a triangle. So there's a little bit more geometry-based kind of conditional statement. If the figure has 3 sides, then it is a triangle. Could have said if the figure is a triangle, then it has 3 sides. I'm totally fine with either one. Even more kind of algebraic here with this one. This one, it can probably truly get by with just inserting the words if and then. So if x is equal to 2, then x squared equals 4. So really, other than kind of getting those words in there, I lost the word when. But notice I'm not solving, I'm not substituting, I'm not plugging anything in. It's just turn it into an if-then. All right. So hopefully that's a skill that we're saying, yep, I can do that. Not too bad. A little bit of writing. Moving on. Negation. All right. So another vocab word that we added to our notes. When we negate a statement, we say the opposite of the original statement. And that can be tougher than you think. You know, the car is black. Some people might say the opposite of that is, oh, the car is white. But that's not really what we're doing here. It's if I said the car is black, the opposite of that statement would be the car is not black. So a lot of times this, with negation, the note that we took, so we didn't say anything, again, with symbols. We didn't do any of that. We didn't do not P or anything. Like, we didn't do anything with that. The big note that we took was most of the time involves adding or removing the word not, or some form of it, you know, aren't, don't, you know, which are all contractions that are do not, are not, hasn't, has not. So stuff like that. So that's, once we kind of know that negate, associate the word negation with the word not, no problem. All right. So we can kind of just talk through these here. If the original statement is the ball is red, the negation of that statement would be the ball is not red. So don't get creative. Don't try to turn, oh, what's the opposite of red? Blue? Or, you know, don't go down that road. It's really involving that word not. We did one similar to this, or I mentioned it before, but let's say my original statement is the cat is not black. Okay. The negation of that involves removing the word not and just saying the cat is black. So we've kind of covered every scenario. Either the cat is black or cat is not black. We didn't say white. We didn't go down trying to figure out opposite of colors or opposite of, up, down. If it's the hot air balloon is up, the hot air balloon is not up would be an example. All right. So that's negation. Nothing really specific example-wise with that, other than maybe adding one of these to your notes. Converse, inverse. So again, there's a lot going on here as far as stuff that we didn't necessarily talk about. The symbols just wasn't part of something that we were doing, so don't worry about that. You don't need to add any of that. You'll never see me write anything like that. The big takeaway is that the converse, so this is one of our vocab words, the converse of a statement, of a conditional statement, it's very mechanical. It's switching, just exchanging the hypothesis and conclusion. So if I went back to it's raining outside, if I click back and forth here, the converse, or here's my original if-then statement. If it is raining, then there are clouds in the sky. The converse of the statement would read, if there are clouds in the sky, then it is raining. Okay, so the converse is a very mechanical, just switch your conclusion and your hypothesis around and read it exactly how it is. Keep the if and the then in the same spots. All right, so that's converse. And sometimes people get these mixed up because they sound the same. The next vocab word we talked about, a type of, another type of conditional statement would be the inverse. So if I ask you, which I will, to write the inverse of a conditional statement, you negate, so and get that word not involved, both the hypothesis and the conclusion. Okay, so going back to our example here, if I said, here's your original if-then statement, I want you to tell me the inverse of this statement, you would say, if it is not raining, then there are not clouds in the sky, or there are no clouds in the sky, something along those lines. All right, so we'll have to practice that here. We'll look at one of those examples. This is kind of the big ticket example for this section for 2.1 is going through all the different if-thens, converse, inverse. We'll also add a little element of true, false here. So here we go. Here's the directions. Write a conditional statement as if-then. So here's our conditional statement. Guitar players are musicians. All right, no problem. The first thing it's asking us to do is turn that into an if-then statement. So that's kind of a repeat skill that we talked about earlier. Based on that, then, write the converse and inverse of that conditional statement. And then we'll do this element of you decide whether each statement is true or false and explain how you know. All right, so let's kind of start at the top here. I'll probably have to slide, and that'll eventually come off there. But if I ask us to turn this into an if-then statement, I think we can do that. Our if-then, for me, I think I would say if if the person, if they are guitar players, then they are musicians. All right, I'm just kind of keeping everything the way it was written. So if, let's just go with you. If you are a guitar player, then you are a musician. You are a musician. Whoops, musician. All right, no problem. So I've taken the conditional statement and just got it in that form. Let's go ahead and do the true-false component of it right away. Now this one's a little bit more open-ended. Some of them will have very clear, I think, definitive true and false. This is a little bit more, what are your opinions on musicians and guitar players? If you feel strongly one way or another, you might argue. I would think the majority of people would say that this is a true statement, that if you are a guitar player, then you are a musician, based on kind of what we understand as what a musician is. So my explanation, or first off, I would say definitely, yes, this is true. And my explanation would be something along the lines, and just as long as you back up what you're saying, why you're justifying true false on one like this, that's a little bit more open-ended. I'm not gonna get bent out of shape. So if you're a guitar player, then you are a musician. Sure, I'm gonna say that's true. A guitar. So here's my explanation. A guitar is a musical instrument. That was covered probably in elementary school music class when you talked about different types of instruments. A guitar is a musical instrument. So the player of a guitar, let's just say the player, we understand that the player of a guitar would be a it's hard to talking, right? Would be a musician. All right. Again, we're not going to be word for word on all these. You're interpreting what's being said there. So don't feel like you have to make yours match like mine. Let's keep plugging away here. So the next thing it asked us to do, and you can scroll back up, but it asked us for the converse of our statement. So just make sure we're always going back up to the original if-then. And we said the mechanics of a converse is switching our hypothesis and conclusion. So my converse would be, if you are a musician, then you are a guitar player. So I've gone back up and I've just said, you know what? I'm going to switch my hypothesis of you are a guitar player with my conclusion, which was you are a musician, and kept everything else kind of how it was. So is that true, false? I'm kind of speaking as a majority like before, that I would think most people would kind of say that that is false. And as long as I justify it and explain why, I think I'll be fine. If you're a musician, then you are a guitar player. Well, I think the explanation there is that not all musicians play guitar, right? You can be a musician, you can play other instruments, you can maybe be a singer. Um, lots of different options as far as being considered what most people would call a musician, and not necessarily playing the guitar. So we just need to summarize that, say that kind of in your own words. Maybe even as short as not all musicians are guitar players. I think that would be totally fine for an explanation. All right, then the last one here, we'll take a look. It was asking us for the inverse of our original if-then statement. So we got to be careful. Sometimes the mistake people make is, all right, I'm going to go up to this one right here. We need to kind of be looking at my original if-then statement. So my original was, if you are a guitar player, then you're a musician. Inverse, again, remember we said the mechanics of that is we're negating, so getting that word not involved twice with the hypothesis. So something along the lines of just, if you are not a guitar player, or if you aren't a guitar player, then you are not a musician. So if you are not a guitar player, if you are not a guitar player, then you are not a musician. So I've negated both musician. All right. So I got to kind of take a step back here before I decide, is that true or false? If you are not a guitar player, then you're not a musician. Seems kind of harsh, right? It's kind of saying you have to play guitar to be a musician. So I think very similar kind of idea as far as what we said for the converse, as far as addressing whether it's true or false. If you're not a guitar player, then you're not a musician. I would definitely say that's false. You do not have to be, let's just kind of word it maybe a little bit differently. You do not have to be, or do not have to play guitar to be a musician. All right. So that one's kind of a fun one as far as like, I mean, fun. I have a lot of writing, so I guess most people wouldn't say that's fun, but just the topic, or you're a little bit of interpretation for it. Could it be more mathy? Absolutely. It could have said, if the angle has a measure of 137 degrees, then the angle is obtuse. That's very cut and dry as far as when we start talking about true and false there. So there are some that are very definitive, true and false. This one's a little bit more looser. So just know that on a quiz or a test, I'd probably give you ones that are a little bit more concrete as far as deciding whether it's true or false. All right, so I think that takes us through writing conditional statements in if-then form. We did that multiple times there. Gone through what is a converse and an inverse. That the inverse involved negating hypothesis and conclusion. The last thing we got to look at here is using properties and definitions to justify conclusions. So 2 slides left. Stay with me here. This is just a straight up more of chapter 1 feel to it of just, here's a vocab word for us, perpendicular lines. So we said in class that perpendicular lines are 2 lines. So this component here for sure, 2 lines that intersect to form a right angle. That's what we said. That's exactly word for word what we said as far as the definition. Two lines that intersect to form a right angle. So make sure we add that. It's a true vocab word. The picture that goes along with it here, I've got line L and line M. The key component here is not necessarily the lines, but this symbol that we've used actually already a couple different times in chapter 1 for a right angle. Right? When we started talking about angles, when we defined what a right angle was, we introduced that symbol. The phrase, so what we could say that's going on in the picture here, that line L is perpendicular to line M, can be way, I don't like this here without saying the word line, but we could definitely say that line L is perpendicular to line, that's supposed to be a cursive M, line M, this is perpendicular to is that symbol right there. So it's kind of a nice shorthand thing to make note of symbol-wise. The reason this comes up, and it's kind of weird, like why we're doing all this negation and converse, inverse, and all of a sudden it's showing up here as what's going on? Why is this coming up kind of randomly? The book defines like the geometry definitions as, they write them as if-then statements. If two lines intersect to form a right angle, then they are perpendicular lines. So that's kind of why it's coming up here. It's just a good time to introduce it, I guess, but also to show that we can write this definition backwards, the converse, remember, flip the hypothesis and conclusion, and it would read, if two lines are perpendicular lines, then they intersect to form a right angle. That's actually what makes something a good definition. Both the original if-then and its converse are true. That's ensuring that we would have a good definition. So a little bit as to why it's coming up here. All right, so last thing, not just on perpendicular lines. This is actually going to force us a little bit to go back to some chapter 1 concepts and just at least recall parts of those definitions. So here's what we're doing. We're deciding whether the statement's true or false, so there's still that component of true, false. But then instead of just saying true because it looks like it, I know, it shows it in the picture, those aren't good explanations. Let's use parts of those definitions to make a stronger claim or make a stronger, just a stronger case for why we're saying true or false. So there's not really a ton of space for me to write here, so let's take a look. So I've got this figure at the right that is asking us about all three. We just talked about part A here when it says line AC is perpendicular to line AB. Yeah, I think that's definitely true. Why? What's my explanation? Again, I don't want to say because of course it's true. We just talked about it. Like, why? How do we know? What part of that definition is showing up here? It's indicated in the figure that line AC intersects line BD at a right angle. So I've taken elements of that definition and kind of customized it a little bit to the specific lines that we were talking about. I don't have to say like as shown in the figure. Like we can all look at the figure. It's intersecting at a right angle. We know that because we've talked about that marking. So I think that's a nice short explanation. Now let's look at two that maybe aren't so, like, we got to look back. That one was fresh in our heads here. For part B, it's saying angle AEB and CEB are a linear pair. Uh-oh. I forgot what a linear pair was. So we're probably going to have to look back. Lesson 1.6, it was towards the end of the lesson. We did all those angle pair relationships. Angle AEB and CEB. So first off, what angles are we talking about? Angle AEB is right here. And angle CEB is right here. So we defined a linear pair as a pair or two angles that are adjacent. Oh, so now I got to know adjacent. And whose non-adjacent sides form a line, essentially. I'm not reading a definition. I'm going off of kind of what I remember about that definition. So let's see, are they adjacent? Yeah, they're sharing this vertex and they're sharing this side. Their non-adjacent sides are forming a line AC. So I would definitely say that, yes, this is also true. My explanation would be including some of that stuff. The angles, let's just say they, referring to the angles, they are adjacent. So I'm trying to make this like manageable and short. So we're not writing an essay. They are adjacent. Non-adjacent sides form line. I already wrote it, so let's just write it out as line AC. Awesome. And the better I am with my vocab and my definitions and just knowing those abbreviations and symbols, I can be concise. I can use adjacent. You actually illustrate to me that, hey, you know what you're talking about. Last one. Let's finish it up so we can keep this under half an hour. Are they opposite rays? I'm going to clear this off here a little bit. Are ray EA? So where is ray EA? It starts at E and goes forever this way. Ray EB starts at E and goes forever this way. I don't think so. Those are not opposite rays. So false. Why? What did we say an opposite ray had to do? They had to share an endpoint, which these are doing, but they also had to lie on the same line. So I would say something along the lines of they, again, referring to the rays, they do not lie on the same line. So that was back in lesson 1.1. Review that, your opposite ray notes on that one if you need to, okay? Oh, so there we go. There's just a couple examples of how we're going to use definitions that we've learned. That's the lesson. So go back, rewatch anything you need to. I think we've definitely hit both of our goals, so we can check them off and kind of close the door on lesson 2.1. So there you have it, lesson 2.1, conditional statement notes. I will see you in future lessons.